Good morning, students. So, in previous class, we were discussing about the chemical reactions of the ether. We have discussed reaction of the ether with hydrogen halide, and today we will keep continue. We will do the electrophilic substitution reactions for ether. Students, as you have already studied in case of phenol, in haloalkane, haloarine, in same way, ether also show the electrophilic substitution reactions. What do you mean by the electrophilic substitution? Electrophilic substitution means when one electrophile replace other nucleophiles, other electrophile. Then type of reaction is known as the electrophilic substitution reaction. Okay, so here, in case of electrophilic substitution is given by the aromatic. Okay. Like phenol, ether also show the resonance. Here, you know very well how can we draw resonating structure. Here, this alkoxide group, it is the shows the pulsar effect. Here it can give the electron to this and this bond can transfer here. In this way, positive charge will come here and this electron transfer here. So in this way you can prepare the resonating structures. You have already prepared in case of phenol also. We are not doing any change here. So we will write as it is. This electron will shift here. This bond will shift at this position. Then further this will shift here. This pair is shifting here and this one here. This is as it is. So students, in same way, we were making the resonating structures for phenol also. So here you can see that electrons are coming at ortho and para position only. Here this position, 1, 2 position is ortho position. This one is also ortho and this one is the para position. So electrons are coming only at the ortho and para position. So they also gives us ortho para directing. Here we will also get ortho para directing products. For example, students, if we want to do halogenation, halogenation means reaction with halogen. So if we do bromination of this in presence of ethanol, we are doing this reaction in presence of ethanol. So students, here first of all we will identify the electrophile, and you know very well here electrophile will generate Br positive because we have already done these reactions in phenol and in haloalkane. So here this will be the electrophile. So you will attach these electrophiles at ortho and para position because Here, this bromine has positive charge on this. So this bromonium ion, it has tendency to gain the electron, and from where it can take the electron, where availability will be, and availability is either on ortho position or at the para position. So student, it will be attached either at ortho or at para. So we will get the ortho para directing products. But here this will be the major product. Here this will be the major product. You know very well how they will be measured due to the symmetry, and due to the less steric hindrance. Clear to you or not? So here para will be the major product and ortho will be the minor product. Students, here, because at every position hydrogen is present, one carbon and one hydrogen is present. So here this bromonium ion is replacing this H positive. Okay, so here one electrophile is replacing the other electrophile. So these reactions are known as the electrophilic substitution reaction. So in case of ether, we will get ortho-para directing products. Why we will get? Because electron density comes at ortho and para. Why it comes on ortho and para? Because OCH3 group it shows the plus R effect. It is clear to you or not? Okay. Our second one reaction is the Friedel-Crafts. Friedel-Crafts reaction. It also show the electrophilic substitution mechanism. Okay. What is the Friedel-Crafts reaction? Here, our substrate is ether. It is anisole. In Friedel-Crafts reaction, either we can take alkyl halide, or we can take acetyl halide or acetyl chloride. Okay. So students, in case of phenol, you were doing the reaction in presence of anhydrous AlCl3. Here you will take anhydrous AlCl3 as well as carbon disulfide. So what will happen? First of all, you will identify nucleophile from here. So in this, you know very well, this chlorine is more electronegative as compared to carbon. So positive charge will attain on this and negative charge will attain on this. Why this polarity generates? Due to presence of this aluminium trichloride, because it behave like Lewis acid. So it will gain the electron from here. So it will help to break this bond. And finally, here methyl cation will generate, which behave like electrophile. Now, attachment of this alkyl group will take place at ortho and para position. So here ortho position is 1,2 position and para is 1,4 position. So you will get products or orthomethyl anisole or paramethyl anisole, but para will be the major product here. This reaction is the naming reaction. It is known as the Friedel-Crafts reaction because here addition of methyl group, addition of alkyl group is taking place. So it is known as the Friedel-Crafts alkylation. Friedel-Crafts alkylation. In same way, student, if we do the reaction with acetyl chloride, so again we will identify the electrophile here. So here what will be the electrophile? Here this chlorine and carbon, further they have electronegativity difference. So in presence of aluminum chloride, they can be break and they will give this ion plus chloride ion. So here this acetyl group, it will be have like the electrophile. It will be have like electrophile. Now attachment of this group will take place at ortho and para position. And you will get the product either this one or this one. Ortho or para you will get. Here again para will be the major product. Student, because here attachment of acetyl group or acyl group is taking place. So this is known as the either Friedel-Crafts acetylation reaction or Friedel-Crafts acylation only. Acylation reaction. And combinedly, both of them are known as Friedel-Crafts reactions. This reaction is clear to you or not? And which mechanism is followed by them? That is electrophilic substitution. Then our next reaction for electrophilic substitution is nitration. For nitration, reaction will be done with by which concentrated HNO3 in presence of concentrated H2SO4. So again student, first of all we will identify the electrophile here. Here I can write nitric acid in this way. In presence of sulfuric acid, it will get break and it will break in this way. Here this nitrogen is less electronegative as compared to this oxygen. So this concentrated sulfuric acid will help to break this bond between oxygen and nitrogen. Here positive charge will attain on nitrogen due to more electropositive as compared to oxygen, and negative charge will goes at oxygen. So here generation of electrophile take place and electrophile is this one. Now further in same way, after identification of the electrophile, you will attach this at ortho and para. Again this will be the major. Student, it does not show the sulfonation in simple conditions because ether is reactive, but it is least reactive. It is least reactive. Clear to you or not? So these are the reactions, electrophilic substitution reactions we have discussed. Now we are going to discuss about physical properties of ether. Physical properties of the ether. First one, they are polar. They are polar. Why they are polar? Because here bond between oxygen and carbon and oxygen have some electronegativity difference. So some positive and negative charge can be generated on them. Due to this, they are polar in nature, but they are very least polar. They are very least polar because there is electronegativity difference, but not so more. They are the least polar. Sometimes we use them like non-polar solvent also. Like non-polar solvent also. Really, they have some net dipole moment because they have some net dipole moment because they are polar in nature, but their polar nature is very least. Sometimes they behave like non-polar solvent also. Clear? Now we will talk about boiling point and melting point of them. Boiling point. Their boiling point is comparable to the alkanes. Corresponding alkanes means which have molecular mass nearly equal to the respective ether. Okay, so they have comparable boiling point to the corresponding alkane, but their boiling point is very less. Their boiling point is very less as compared to boiling point of alcohol. Boiling point of the alcohol. Why it is? Because ether molecules do not form hydrogen bonding. They have some dipole interaction only. They have some dipole interaction. They do not form intermolecular hydrogen bond. For example, here I have already told you that they are polar. Some polarity is here. So negative charge will attain on this and positive charge will attain on this. When we take one other molecule of this, like this, so again negative charge partially and partially positive charge on this one. So due to the positive and negative charge separation, some attraction may be there. But this attraction is between carbon and oxygen, not between carbon and hydrogen. So this attraction is known as the dipole interaction. Okay. So students, they show the dipole interaction between them. But alcohol they form intermolecular hydrogen bonding. They form intermolecular hydrogen bonding them. Due to formation of the intermolecular hydrogen bonding. Hydrogen bonding means bond between hydrogen and more electronegative element. Due to the hydrogen bonding, they have more boiling point as compared to the ether. If we compare N-pentane and ethoxyethane, and we have butane-1-ol. If we calculate their molecular mass, then they will have comparable molecular mass. But student, their boiling point is, it has boiling point nearly equal to 309. It has boiling point nearly 307, and it has boiling point approx 390 Kelvin. You can see all these three have comparable molecular mass, but there is difference between their boiling point. Boiling point of alkane and ether is comparable, but alcohol has more boiling point. There is a lot of difference between boiling point of ether and alcohol. Why it is? Because they form intermolecular hydrogen bonding. We have already discussed now. They form intermolecular hydrogen bonding. But they do not form intermolecular hydrogen bonding. They have only dipole-dipole interaction. They have only dipole-dipole interaction only. So they can be break easily. So their boiling point is low. It is clear to you or not? Our last point for physical property is solubility. Students, they are soluble in water like alcohol. At which extent alcohol dissolve into the water, at the same extent they can be dissolved. At the comparable extent they can be dissolved into the water. Why? Because they are not forming intermolecular hydrogen bonding with molecules of itself, but they form hydrogen bonding with the molecule of the water. You can see, if we have CH3, CO, CH3, this is ether, and alcohol, ROH. If we have one molecule of ether and one molecule of water, so student, they form bond. They form hydrogen bond with the water molecule. Due to formation of hydrogen bond with the water molecules, they are miscible in water. Means they are soluble in water. Clear to you or not? So today we have discussed about physical properties of ether and electrophilic substitution reactions for ether. Almost we have completed this unit. Okay. So students, from tomorrow we will start exercise portion of this. I hope this is clear to you. So thank you. Have a nice day.